Hello, I am Kim Kun from India of France. In this video, I would like to present our recent work about learning in Markovian bandits, especially how posterior sampling and optimism compare. This work was jointly developed by Nicolas Gast and Bruno Gojal from India. Okay, let's start. We are interested in a reinforcement learning problem in which the environment is a Markovian bandit composed of n Markov reward processes. Each process has S states. At each decision time, the agent observes the current state of all arms and decides to pull one arm. The chosen arm incurs a reward and make a transition to new state according to some probability distribution. The unchosen arm remain in the same current state. When the Markovian bandit is known, the best way to maximize the value from the bandit is to follow Gittin's index policy. However, in our learning setting, the agent has no initial knowledge about the Markovian bandit and interacts with it according to its policy, which is updated after some number of time steps that is chosen according to a geometric distribution. So this is known as an episodic learning setting. The goal of the agent is to ultimately identify the optimal policy that maximizes the value from the bandit while minimizing its episodic regret. I would like to highlight that in this learning problem, the environment is a Markov decision process, or MDP in short, having s to the power of n states and n actions. To make the agent achieve its goal, there are two approaches in reinforcement learning. One is posterior sampling, in which the unknown MDP is assumed to be drawn from some probability distribution. When planning, the agent draws a sample from the posterior distribution, computes an optimal policy in the sampled MDP, and then follows the computed policy when interacting with the unknown MDP. The agent collects observations and uses them to refine the posterior distribution about the unknown MDP and repeats the planning process. The classical algorithm of such approach is PSOL by Osborne et al. The other approach is optimism in face of uncertainty, which maintains a confidence set that contains the unknown MDP with high probability. When planning, the agent chooses a MDP from the set such that the maximal value of the chosen MDP is at least the maximal value of the unknown MDP. After that, the agent computes an optimal policy in the chosen MDP and follows the computed policy when interacting with the unknown MDP. The agent collects observations, uses them to refine the confidence set, and repeats the planning process. Two classical algorithms for such approach that we consider in our work are UCLL2 that constructs confidence set for reward and state transition, and UCBBI that constructs confidence set only for reward. Without any adaptation, the three algorithms have a regret and runtime exponential in the number of arms in learning Markovian bandit. However, the three algorithms can be adapted to the structure of this learning problem. And in our work, we show that their modified version MBPSOL, MBUCOL2, MBUCBBI all have a regrade that is sublinear in the number of arms. For computational complexity, MBPSOL, MBUCBBI can leverage Gittin's index policy to have a runtime that is linear in the number of arms, but MBUCLL2 cannot. In fact, we show that UCLL2 and its variants cannot be adapted to have a linear runtime in our learning problem because they use confidence set for state transition. To find out how we remove the exponentiality in the number of arms from the regret of the 3MB algorithms and why the confidence set for state transition is a problem for MBUCL2, we invite you to read our paper.